All right, guys. Finally, here's part 3. This is what's going to be on Wednesday. I know some of you may be starting your finals by then, so definitely you're going to want to take a look. This is what you're going to miss. Okay, so number 25. All right, at a buffet restaurant, dinner for an adult is $5.95. Price for a child is $4.25. A group of 10 people went to the restaurant for dinner and paid a total of $52.70. And how many adults were in the group? So again, just like the last problem, it's 2 pieces. Okay, I've got my adults, I've got my children. Okay, and I know that there are 10 total people going. Okay, then I know per adult it's $5.95. Okay, I know that for a child it is $4.25. Okay, and I know that my bill costs $52.70. So what I'm going to do here is I'm going to eliminate, okay, because it wants how many adults, so I'm going to eliminate children. As fun as that sounds, we're going to move past that. Okay, so to eliminate children, I need to have the opposite of my children here. I'll just rewrite this so it's a little bit clearer instead of trying to squeeze things in. All right, we will, that's 52.70, okay. So I'm going to go ahead and I'm going to multiply by the opposite of the children on the bottom there. So I'm going to multiply my top by negative 4.25, just so that way I can eliminate right away. So I end up with negative 4.25a minus 4.25c. Okay, and finally is equal to negative 42.5. Okay, I don't know why I even bothered doing that. I should just erase it immediately. All right, so that's what we're looking at. Okay, I go ahead and add my 2 lines straight down. So $5.95 minus $4.25 is $1.70. Okay, so I have $1.70 here. Okay, adults, my children eliminate themselves. Okay, and then $52.70 minus $42.50 is $10.20 here, so 10.2. Okay, I go ahead, I do my division, and I find out that there are exactly 6 adults. Okay, number 26, this is off of one of your previous tests, word for word. Okay, this is the one where we have multiple equations to represent our piece over there. So there's going to be exactly 4 because there's 4 lines there. So we have 4 different equations. Okay, what we're going to do is start with the easy ones first. Okay, so the easy ones are going to be my horizontal ones. Okay, I've got one here and I've got one here. Okay, the top one, we look at the y-coordinates. So the top one happens at 3. The bottom one happens at 0. Now I got to look at the shading. If I look at the top, okay, it looks like the shading is below. So I'm going to use less than, and they're all solid lines, so I have or equal to. Okay, if I look at the bottom, shading is above that line, so therefore greater than or equal to. Okay, now I got to take care of the sidelines. The sidelines are a little bit more difficult here. Okay, just because you're going to have to kind of visualize what you're looking at here. Okay, so if I start with this one, all right. So what I'm going to do is I'm going to first figure out what my slope is. So if I do this, I'm going to count this. It's 1, 2, 3. So it's up 3, right 1. So my slope would be 3x here. Okay. Now it looks like for every time I go up 3, I have to go over 1. So because of this, I need to make my x-coordinate 0. If I'm looking at that, in order to do that right now, I'm sitting at negative 2 right here. Okay, so the next time that I do a slope, I'd go up 3 and over 1, which that would give me the negative 1, and then I'd have to go up 3 and over 1 again to get me to 0. So it looks like my 0 coordinate, my y, is going to be 9. Okay, I'm going to tell you right now that when you do this one, you're going to end up with the exact same thing. Okay, the difference is for this side, okay, the only difference is going to be what is my slope. All right, my slope is up 1, 2, 3. And instead of going right, I go left, which is going to make that a negative slope. Okay, all right, now I got to do this. Looking at the line on the left, my shading is below, so therefore less than or equal to. Looking at the line on the right, my shading is below, so therefore less than or equal to. Okay, so there's that problem there. I know that was tough, but fight through it, okay? That's about all I can say on that. Number 27, solution to the system of equations here. So there's three. Remember, we start at the bottom, work our way up. So first things first, I have 2z equals 4. To figure out z, all I gotta do is divide by 2, so z is 2. Okay, now I'm gonna take that 2, I'm gonna plug it into the line above it. So I have y plus 2 times 2 is equal to 0. So I would end up with y plus 4 equals 0, which tells me that y is negative 4. Okay, cool, I've got 2 of the 3. Finally, I have to get the third one, so I go ahead and plug it in the top line. So x plus 2 times negative 4 plus 3 times 2 is equal to 6. All right, so I'm going to have x minus 8 plus 6 equals 6. So I believe, if I do this correctly here, yeah, I don't know why I just stopped there. Okay, negative 8 plus 6, okay, is going to, excuse me, bring me to a negative 2, okay? And I need to get rid of that negative 2, so I'm going to add it. Gives me 8. Okay, the answer here should be written as x, comma, y, comma, z. All right, so there you go. Number 28. Okay, write an equation that is parallel to this line. Okay, so remember parallel, we're looking for the same slope. Okay, so that means when this equation is written, what you're looking for in your answer is the slopes to match. So specifically this piece right here. Okay, afterwards it's any number but 5, so you can throw anything here. So I'm just going to throw minus 2. I don't know exactly what it's going to look like on the test because it's not a free response question. It's one where you're going to have to pick. So look for the one with the same slope. Okay. Number 29, okay, when graphed, oh my gosh, come on now. When graphed in standard form, which one of these is going to represent a quadratic? So remember, a quadratic needs to have an x squared in it, okay? So the only one with x squared in it, just by looking at it, is D. There is zero work here. I'm looking for an x squared, okay? The only time you gotta be careful is if there is like terms, then you gotta combine those first, but in this case there isn't, so you are good to go just by finding an x squared situation, all right? Number 30, okay, the vertex of a parabola is 2, 4, and the y-intercept are 0, 6. What is the reflection of the y-intercept? Okay, so looking for, remember when we drew our graphs, we would draw straight across for that. Okay, so this is when we're going to have to visualize. Okay, so, all right, I have, if I'm doing this, and again, this is going to be kind of crappy, so I have 2, 4 here. Okay, if I make like a quick makeshift graph, that's not a good spot for that line. Shoot. Okay, each line is going to represent 2 because I don't have a lot of space here. 1, 2, 3, 4, 5, 6. Okay, so I'm just going to go ahead and kind of visualize this. Okay, so over 2 of 4 is roughly here. Okay, for the vertical, this is 4, 2, 6, and so on. Okay, so it says that the vertex is over here. I'm sorry, the vertex is at 2, 4. Okay, the y-intercept is over there. So that means my other point needs to be to the right of it. So it looks like if I go over 2, I should go up 2. So in this case, I'm going to go up. I'm going to go over 2 this way. So that puts me at 4. And remember, your y-coordinate should remain the same when you're talking y-intercept reflection points, okay? That one's a tough one, but again, it's just visualize it, all right? 31, what is the vertex of this? So remember, we are in standard form. We're talking A, we're talking B, we're talking C, okay? And also remember that we use this wonderful formula, and hopefully it's engraved into your head by now. And if it's not, then I don't know how to help you. Opposite of B over 2A, okay? We use it so much, okay, during that last test, okay? So the opposite of the opposite of B here is a positive 12. On the bottom, I have 2 times A, okay? So I believe when you simplify that, 12 divided by negative 6 is indeed negative 2. So that's my x-coordinate of my vertex. Okay, the y-coordinate I get by plugging in the x. So I go ahead and do that. 3 times negative 2 squared minus 12 times negative 2 minus 8 I go ahead, I plug that directly into a calculator because I'm not about to do that work in my head, and I get 4. This gives me 4. That is my y-coordinate. So there's my answer, -2, 4. All right. Number 32, a skating rink finds that revenue R is based on the hourly fee. Skating is represented by that function there. And it says, what fee will we produce? Okay, it's not asking you about max revenue, it's just asking you about fee. Fee is in the X spot, so once again, we are just using the opposite of B over 2A. Okay, so this is all I have to do. So the opposite of B is -3,120. Okay, I have 2 times my A value, which is -240. Okay, I go ahead, I just type that into my calculator. Remember, you can type the whole thing into your calculator if you'd like, if you just put parentheses around the entire bottom. Okay, if you do that, you will end up with the fee is $6.50. All right, so there's that question there. Number 33. Okay, 33. You guys, okay, we've got, write an equation that represents the graph over there. Okay, so we're going to start simply, we're going to start with our vertex. Okay, so our vertex is right here. All right, so that looks to me like it is -1, 1. So there's my vertex. So if I'm looking at that, my general equation for us is going to be this. Okay, assume if they don't give you any information about A, that A is going to be 1. So in this case, I'm just going to assume that A is 1. Actually, technically, I can't assume that. I got to actually plug in, so we'll do that really quick. So y is equal to A times x plus 1 squared plus 1. Okay, remember, opposite of h, then going for k. Okay, I got to pick another point on this graph, so I'll pick it right here because that's an easy point to use. The point in red that I picked is 0, 2. So that way, that's my plug-in. So in this case, y is 2, A, I don't know yet, x is 0. I go ahead and do this. I have 2 equals 1A plus 1. Okay, so I'm going to subtract 1, so A is equal to 1. So in this case, A ended up being 1 for us, so y equals x plus 1 squared plus 4. Okay, it's just plugging into our formula and being happy with it. All right, find the minimum. Okay, so remember the minimum, guys, will be the y-coordinate of the vertex. So basically what this is asking you to do is figure out what the y-coordinate of the vertex is. So remember, if we're in vertex form here, I've got my h, I've got my k. So when I'm thinking about it though, remember it's always opposite of h for us, so that would be -4, and 6 stays the same. It's always going to be our k coordinate. So in this case, my answer will be y equals 6. Okay, not bad. Find the y-intercept of that function. So remember, y-intercept, another way to do y-intercept is just plug in 0 for x. So if I do that, I shall have -2 times 0 plus 4 squared plus 6. Well, this is easy. 4 plus 0 is 4, so 4 squared is 16. So I'm going to have -2 times 16, which is -32 plus 6. Okay, so -32 plus 6 is going to be -26. So that is the y-coordinate. So that means for my answer, I have 0, -26. All right, and that is your final. Okay, there is nothing more to it than that. And honestly, guys, this is something that I really think we can succeed on. It's not overly difficult. Of course, you're going to have to study to get things done correctly. Okay. Other than that, if you have questions, please ask. That's what I'm here for. And yeah.